Hello everyone, welcome to the second tutorial of the Advanced Building Information Modeling course. I'll start with the first section in this tutorial, which is modeling conceptual mass with a hole. So first we'll need to select the metric mass template for our model. So I'll start with it. Instead of creating a new project file for our model, we'll select new family, and then under the English folder we'll find the conceptual mass folder, and then we'll select the metric mass family template and then click open. So if you want to change the background color of your view, then you just need to go to File, Options, and then the Graphics, and from here you can change the color, and if you want it to keep it semi-transparent or not, you can move the tick here. I'll keep it the way it is, and then continue with the second page. So I'll switch to the north view in the elevations, set the scale to 1 to 500, and then draw a new level at 30,000 millimeters. So I'll add a new level. Alright. So I'll type escape to get out of the command, and then head to level 1 on the draw plans. So I'll start by drawing the square we need by clicking on rectangle option, and then several ways to draw it. So the easiest for me is just to make sure the surface from closed loops option is ticked on, and 3D snapping as well. And then I'll start from the center point to I get the 3000 I need. And then select Worth. And then move it from the midpoint. Then type enter again and move it from the midpoint to the axis again. And now it's centered, so I'll type escape and then head back to the 3D view. So now we have our plane here. To create a 3D solid cube, I'll just extrude it in Z direction. So under create form, I'll select solid form, and from here we can just set the height from 10,000 to 30,000, and now we have our cube. If you check in the north again, it's a square reaching exactly level 2. So to rotate it, I'll get back to the 3D view and then select the upper surface, and then select rotate, and you can specify the angle here by 30 degrees, and then type enter, or you can do it from the if I type Ctrl Z and then select the surface again, then click on rotate, and then use the axis here to visually rotate. So I'll keep the angle at 30 degrees. Do it this way as well. To create the void cylinder in the middle, I'll move back to the plan view. So I'll head back to level 1, and then create a circle of 10,000 millimeters in radius. So this time I'll select the circle, and on the center point I'll just draw 2 pictures 10,000. So now we have the circle, and it's the surface as well. So because we have the activated option for make surface for closed loops. So I'll type escape to get out of the command. I'll return back to the 3D view. So if you try, as you can see, if you try to select the circular plane, it might be a bit difficult to get a grip of it. So the easiest way is just to get the rotated cube out of the way. So for that, I'll just use the temporary hide element option. To extrude the circle, I'll just use a window selection, and then under create form, I'll select the option for a void form, and as you can see, the extrusion is upwards, so I'll have to change it downwards. So instead of 8,000, I'll just use minus 30,000 and type enter, and now it's extruding to the rotated cube and creating the void itself. So I'll deactivate the isolation option, and now we have it in 3D viewed model. So I'll save my new family I've created here by going to File tab, and then Save as Family. I'll save it to the desktop and rename it as Conceptual Mastery Tool. And then click Save. So to use the family we've just created in a project, I'll just create a new project. So project, I'll select the metric construction template, and then select OK. So I'll close the data element here. The easiest way is if you're having the family file already opened in a tab, you can just load it into a project, and it will recognize the project already opened. Or you can just insert it from here. So insert and then load family. Both options work. So I'll do it the other way around from here. I'll just load it into project. And then select close here. And I will place it, I guess, somewhere here. And then type escape. Get to the 3D view. I don't have one, so I'll just create one quickly. And then you can see it's already visible here. Moving on to the second section of the tutorial, to model a column with a capital as a rotating form, I'll select a new family in the English folder, and then I'll select the metric column.rft. We don't need the parameters for the depth and width, so I'll go to the family types and then select the depth, and I'll delete the parameter and confirm the deletion. The same for width as well, and I'll click yes, and then I'll click OK. I'll move to the front elevation view to draw the reference planes we need as shown in the PDF. So I'll start by clicking on reference plane and then starting in here. You can just type the value once you have the reference dimension here in blue. You can just type the value you need. So I'll start by 300 and then continue with the next one at 50 millimeters, then type enter. The next one is at 1750 millimeters, and then I'll type enter. $50 millimeters, and then 1500, and another 50 millimeters. I'll type escape to get out of the command and then continue for the vertical reference planes. So we need one here at 100 millimeter distance, and the next one is almost 50 millimeters. So I'll type 50 and then go to the other side. I'll type escape to get out of the command and then I'll draw the annotated dimensions. So here you'll find the align dimension, and then I'll just click on the first reference level and then continue to the next and then the next and so on and so forth. Then I'll draw the dimensions for the vertical reference planes. So I'll start from this one and then select the next and the next, and just select somewhere here and type escape. If the dimensions are overlapping, then the scaling is just a bit large. You can just make it a bit smaller and then we'll see the dimensions. To draw the column, I'll start by drawing the profile along the axis we want to revolve around. So I'll go to create and then select revolve. We can select the axis line we need, so I'll just use the pick lines option and select the central axis here. For the boundary line, to draw the profile, I'll start as in the PDF from here and continue all the way to the very first point. Make sure at each point you draw the line, the intersection and horizontal. Magenta sign is activated, so the points are attached to the reference planes you're using. And then the last line all the way back to the top of the column. And then I'll click on finish edit mode. Now you see the column is already modeled. You can check it in the 3D view as well. So, and then I'll save the new family as column with capital.rfa. On the desktop. Moving on to the third section, parametrics. I opened the building we modeled last time in the first tutorial. So to change the parameters of the column, you can select one and select on edit type. And here you can change beam edge or depth and width depending on which family of columns we've used. So if we switch it to 600 by 600, and click apply, you'll notice that the dimensions have changed here as well. I'll get them back to 300 and click OK. You can change the parameters as well from the family itself, so you have to edit the family file by clicking on edit family here, or by just double clicking on the column itself. It will turn the family file, as you can see here. It's a concrete rectangular.rfa, and you can see it in the plans that the column is 300 by 450 millimeters. So to change the columns parameters, you go to family types and then change the values here as well. So if I do them as 600 and 600, and then click apply, the parameters will change as well here. So put them at 400 and 600. The dimensions will change as well. So I'll type cancel and type Ctrl Z to return it back to the original values. Of course, without saving, and return back to the model. So if you want to change the level of the height of the second level, we can go to the elevations, view. So to change the height of the second level, you can just click on it and change the value to 4200. You'll notice there's an error because of the staircase. The height is not updated, and mainly because the beams as well are not related to the second level. So to change that, we'll just select the beams. You can just do window selection and filter out slabs, and then change the reference level from the first to the second, and then set the offset to 0. And click apply. Now they're updated. Moving on to section 4, to create the parametrics for the column we've just modeled. I'll open the file again you've just saved. and I'll go to the floor plan. If the column is not centered, we just have to select it and detach it from the work plane, and then use the move option, select this intersection point here and move it to the midpoint here. Once the column is centered, then we'll move on to creating the parameters we need. If the column is not centered, you just have to select it I'll move to the then I'll move to the lower reference level for the floor plan. If the column is not centered, we just have to select it and dissociate it from the work plane, and then use the move option and move it to the midpoint. To create the parameter for the diameter, I'll just click on Align Dimension and create a dimension for the diameter from here to here, and then type it. I'll type escape to get out of the command. And then select it. And then I'll create a parameter for it. And then I'll select it and create a parameter for it. the name would be diameter. And then I'll select OK. Then notice here that we got a new parameter. And if you click on edit type, and if you click on family types, you'll find the diameter here, and you can change it. So I'll make it 715, and then apply, and you see it has expanded. I'll check it in the 3D view as well. So I'll click OK for now, and then go to the 3D view, and then click again on family types, and change it again to 600. Then click apply, and you see it will get back to now again. I'll click OK. To create a parameter for the joint width, I'll just get back to the elevation form view, and then click on align dimension. Click escape. So I'll remove the old dimensions. And start the align dimensions for the joint width parameter. So I'll click on the align dimension and draw the dimensions for the align joints. and then do it for the third one. Then type escape. I'll select 3 dimensions and click on create parameter, and then give them the new parameter join grid. Then click OK. To enforce equality, I'll add a reference plane at the mid distance between the two reference planes here. So I'll get back to the create tab and then select reference plane. And since the distance between both of them is 50, I'll draw it at 25 millimeters. The same here. And then I'll add another align dimension from here to here. Then I'll add another align dimension and activate the equality condition for it and type escape. I'll add 2 more parameters for the capital height and the base height. So for the base height, I'll just add another. to create the parameters for the column with the capital, I'll start with the join grid parameter. So I'll start with the joint width parameter. For that, I'll add a line dimension from here to here, and then this somewhere here. The same for this one as well, and third one. And then I'll type escape. I'll add another dimension for the column height and base height. So once I'll add another dimension for the column height. I'll add another dimension for the capital height, and another for the base height. To enforce the equality at the join grid in the middle, I'll just add one more reference plane. So I'll go to the create tab and then reference, and draw a reference between both of them. So the distance between them is 50 millimeters, so it should be at 25. And then type escape. To enforce the equality, I'll just click again on align dimension, and this time I'll select the first reference plane, then the second, then continue with the third, and then just click somewhere in between, and then type, and then you'll see the equality dimension toggle, and I'll have to turn it on. Now they'll be forced to be equal. Then I'll add the parameters for the joint width by just typing control while selecting both of them. Then I'll add the joint width parameters by just selecting the first dimension and then typing control while selecting the second and the third. And then I'll create a parameter and I'll call it joint dimension. Then I'll call it joint. And then I'll name it joint width. and click OK. For the capital height, I'll select the dimension and then create a new parameter and call it capital height. And click OK. And the same for base height here. So I'll select it, click on create parameter and type base height for the name and click OK. To adjust to parameterize, to add an equality condition for the length of the elements, I'll use another align dimension from here. We'll add another align dimension from this one to the center line between both of them and to this one. And then we're here. And then I'll type escape. So if you try to force an equality by turning on the toggle, most likely you'll get a notification for an error here. And if you check the second message for the warning, it says the highlighted lines are overlapped, but if you try to show them, you might not be able to see them. And it's mainly because, as you can see here, the dimensions have increased, but those lines got overlapped because of the increase here. So I'll just cancel, and an easy way to fix the problem is just by going to the family types and then change the base height to 550. And now if you try to force the equality, it will work. So I'll just select those dimensions and move them slightly to align with the rest. And now it looks much better. So I'll tap escape and save the family again. So I'll create a new empty project and then try to import the parametric column family into it. So I'll just go to File, New Project, and select the metric construction template and select OK. This time I'll go to the Insert tab and do it from here. So I'll load a family, and it's saved at the desktop, and it's the column with capital. And I'll click Open. If you find yourself in this situation where you cannot find the column attached to your mouse here, or you cannot find it, it's usually here under the families in the project browser, and then you have to go to whichever family you've chosen for the column, which is a column family. So we'll go to columns here, and then we'll find our column with capital here. You can just open it, and then you'll find the column with the thumbnail for the shape of the column, and then you can just drag and drop it here. You can place 1, 2, 3 the way you want it, and then type escape, another escape to finish it, and you can see them in the 3D view if you want. Again, no 3D views, so I'll create one quickly. And here they are. If you click one and then if you select one and then try to change the type, we'll see the diameter and the base height and the joint width, all the parameters are here. But if you try to change the diameter, for instance, to 900 and click apply, the diameter of all columns will change simultaneously. So to change the parameter into an instance type, I'll just click OK, and then either you go back to you change the family file itself, or you can just double click on it and it will return you back to the family file. And here you can again go to the family types and then select the diameter, and then you can edit the parameter and change it from a type parameter to an instance parameter, and then click OK, and then click another OK here, and you can just load it into project and close and click yes. And then once you return back to the window or the tab for the project, you'll have to overwrite the current version of the family within the project. And this time, if you select the column, you'll find it here in the properties of the column that you can change it for each instance. So this time, if I change it to 900 the diameter, only this column will change. And I can change this one as well to 800 millimeters and then click apply. For this one, I'll select it and then change the value to 600, and then it will be thinner.